Everyone need to pin me on your screen. Can you see?
Yes, yes.
Okay. Okay, so the card will be look like this. This is for 1,000. Okay, can you see the 1,000 for 1,000 number, and it also can be 10,000. Okay, it can be any number. Up to you. So today, we need to use a piece of paper. Okay, as you can see here, it a piece of A4 paper, but I've divide it into 4 parts. Okay, you can see it, 4 parts. But you can see here only 3 parts because one part have become this. Okay, 4 parts, and we cut off one part. Sorry everyone, I'm a little bit nervous, so if you have any question, you can ask me, okay? Okay, now we have a piece of paper but long one. Okay, we actually, if you search it on YouTube, you can find how to do this card. But this version of card is my version, so I've changed a little bit how to do it. Okay, so first you determine the size of the block you want. The block mean this one block. Okay, one block. This one block. You need to determine how big you want. Okay, and you need to one number. Okay, like this. This is 5 number, right? 5 digit. So there will be 15 block because one number will consist of 3 block. One for number, two for the words. Okay. Okay. Then we fold it into 15 blocks. Fold it nicely. Okay, then we open. We will get the line. Actually, you need to divide it. You need to measure it and divide it carefully. But I'm doing it fast. So we'll count how much block we have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay. Like I said, we need to 3 part, right? So this is 14. So we cannot do 14. We must use 15. So I cut 2 parts. So we can use 4 times 3 is 12. So we can use a 4-digit number. Do everyone understand what I said? Okay, never mind.
Yes.
Yeah.
And
Okay.
Understand.
Okay, if you don't understand, just tell me, okay? Okay, now
Okay.
fold it. Okay, 2 part. Fold it together. And put it behind 1 part. Okay. Okay, so this 3 part. 1, 2, behind a part. Okay, then another 2 part. Fold it together. Put behind 1 part. Okay. Okay, another 2 part. Fold it together. Put behind 1 part. If you want to understand more clearly, you need to do it with me. Okay. Then 2 part behind 1 part. Okay. So now we have 4 column, 4 blocks that will be open like that. Okay. Okay, give me a number, 1,000 number to write in this paper. Can anyone?
3,000.
3,000. More?
800.
800.
30.
30 eh?
35.
Oh, okay, 35. Okay, 35. 3,835. Okay. Okay, sorry. Okay, now you can see 3,835. Sorry, the file is not really clear. Okay. And if we open, we can put anything there. Like in the YouTube, they put place value. So there will be 1,000, 100, 10, and ones. But right now, for our group, we need to present about how to read a big number. So then we need to write here then how to pronounce or how to read this number. Okay, we put 3,000. Sorry. In the 3 column, we put 3,000. Then 800. 30, we put 30. 5, we put 5. Okay. So if we close it, it will be like this. Right? 3,835. Student, actually they won't be able to read it. Then they need to open the card, the folding card. Then they can read it. 3,835. Sorry, madam. Do we need to write N? Like 3,835? Do we need to put the N?
The N is between hundreds and tens.
Hundreds and tens. So do we need to write it in our card?
3,800 and if you're writing in this system like how you are doing, then better put lah, because you're teaching them how to read. Better lah, Izzat. Put 3,835.
Okay, so we can put maybe here and so the student will read 3,835. If you want to teach them about how to read or writing the big numbers, I have another example, but this is I've done first. That okay, as you can see, it is a 1,000 number also, 2,651, and the writing there is the place value, which is 1,000, 100, 10, and 1. So you can also use this to teach about place value. And also digit value, if you want to teach them, you can put 000 here. Then here is 00 to make them understand about anything you want to teach. So you can apply this in various situation, any other situation that's suitable for our mathematics teaching. Okay, that's all about how to do the folding card. Do anyone have any question?
I think no, Aizat.
Is there any more
Okay.
in this group?
My other group will show their
Card,
folding
okay.
card.
Alright, then we will ask
Then
in the end.
how to
Okay.
do the folding card. Okay. That's all from me. I pass it to my other member, Abdul Rahman. Thank you.
Alright, thank you, Aizat. So I will show to you all about just same as Aizat show to you all. I did a 10,000 number and I wrote about just like Aizat how to read the numbers, right? But I write about the place value of the numbers. As example, you can see this is the numbers 78,356. You can see, right? Or it's empat tak? Right.
52 Rahman. 52.
52. Oh, sorry. Okay. 78,352. So when we open it, it will be like this. 7 is a 10,000s. 8 is a thousands. 3 is a hundreds. 5 is a tens. And 2 is a ones. So when the children open up and read this folding paper or folding card, they will know when the 10,000s number shown like this, they will know where is the 10,000s, what is the place value of each numbers. So that's all. So, and I'll pass to Yana.
Okay, so I will show you about my card. So this is my card. As you can see here, I am using digit value. So as Aizat and Rahman did, they did about place value, but I use digit value here. So you can see if I close it like this, it will only appear like one number. But if we open the card, we can see that 9,000 we have 3 zeros, so we put 0 here and then we put symbol here. And also at the bottom of this card, I also put how we used to teach the number. And so this is 9,700, so we put 2 zero here. So here is hundreds, and this is symbol 80, 10. So this is how we use it. We read it 80 and symbol, and last one is 5. And how we used to read it is 5. So my camera is a bit small. So as you can see here, if we read all this, it will appear as number 9,785. So that's all from me. I will pass it to Daniel Irfan.
Hello. Sorry. Okay. This same like other of my fellow mates. Same thing, and I'm using doing the digit value, as you can see. So it is so easy. Is as we can see the four numbers. Yeah. So students or people that want to learn it, so they can open one and another. So for example, 4, and then the number beside it that has 30, it means 4,000. Then 8 to 0 means 100, 10 means 20, and 9. So they read 4,829. Okay, that's all from our group. Okay, thank you.
Okay, I hope everyone understand and enjoy our presentation. For correction, one that Yana and Daniel did just now is called expanded notation. That is Madam said, and you can see in the comment. Okay, that's all from our group. Thank you very much.
Okay, thank you for this group. You all you showed very well. I just want to show one more example. I want Rahman to show the number. Can you show the number, Rahman?
All right, madam.
Okay, hold up, Rahman.
This number?
Yes. So after the 2, do you have a ones there?
Yes, once.
Okay, can you don't open the whole number, just the last ones. Open the ones with the whole number.
With
Okay.
the whole number.
Okay, so that means we are teaching place value. So this number can also means there are 78,352 ones, or close the ones, open the ones and open the tens. Okay, so this number is also 77,835 tens and 2 ones. Okay, now open the hundreds. Okay, so this number, it also means that it is 783 hundreds, 5 tens and 2 ones. Okay, this is how we use this folding number place value cards. We can show the student that the number can be read in many ways. It can be 78,352 ones, or 7,835 tens, or 783 hundreds, 5 tens, 2 ones, and so on. Okay, so this is one way of using it. Okay, thank you, Rahman.
All right.
Okay, so you have seen two ways of using these cards. One is for place value, and one is like how Aizat showed you all earlier, just to teach them how to read the numbers. Okay, so thank you very much to this group 1. Well done, yeah. So let's continue with group 2.
Okay, wait.
Hello.
Okay.
Okay, good evening to Madam and everyone. Today, our group, which is me, Izati, Masturina, Ainazrina, Nur Ain Yasirah, and Muhammad Afi Aiman, represent about models for representing numbers. Okay, next. Okay, our task is to explain the type of models for representing numbers, which are ungroup and pre-group, proportional and non-proportional, and give examples of models for each category and examples on how to represent number with these models. Okay, next. Okay, next. Okay, first thing first, we're going to look at the contents of the ungroup models. Okay, so what is ungroup models? Basically, ungroup models is usually used to introduce or represent the base 10 number system by using concrete manipulatives. As what you already know, concrete manipulatives is any various objects or materials that student can touch and move it around in order to help them learn mathematical concepts. And ungroup models most clearly reflects the relationships of ones and tens. For instance, The 10 can actually be made by grouping the singles. For example, if a student wants to form a group of 10 cubes, he can put 10 units of singular cubes into a group without physically intact or glue them together. So these can be called put together or take apart models. For the concrete manipulative that was used in this models are singular. You can use bean, button, straw, or cube, and these singulars can be made into groups of 10 or base 10 as we call it. Okay, so this is the examples of ungrouped models, such as singular units cube, beans, popsicle sticks, and unifix cubes. Basically, unifix cubes come as singular blocks. However, they can be linked together to make larger group, but nevertheless, they are not permanently intact. Okay, next. Okay, now how to represent numbers using ungrouped models. For the first one, to represent number 7, we put together 7 units of singular cubes together, like in the picture, without physically attach or glue them all together. And for the second one, to represent number 15, we put together 15 pieces of popsicle sticks, like in the picture. Okay, I think that's all from me for the ungrouped models. Next presenter.
Okay, next we go through for the pre-group models. Okay, those that have already been put into groups of 10. For example, 10 straws in a bunch, 10 bits or beans that have been stuck together in a group of 10, and 10 cube already made as one big group of 10. As you can see for the picture beside this. Okay, next. Okay, this is the examples of pre-group models. Pre-group models include like base 10 models, bundles of stick and symbols, strip of them, groups of linking cubes, and single stem frames. The first one is base 10 models. The red one is 1000, the blue one is 100, and the green is 10, while the last one yellow is like once. Okay, a second one, bundles of stick, and then the last one is number root and cards. That's all from me. Sorry, how to represent numbers using pre-group models. Okay, for example, this lesson helps students see that 363 objects that can be represented as groups of hundreds, tens, and ones using pre-group models. For example, the tens will be 330, and then ones will be 5. So the numbers in 35 can be using the using the 10 base 10 models or the stick, like just like straw and other long stick. That's all from me.
Okay, now we go to the proportional and non-proportional model. Okay, I'm presenting about proportional model. Okay, what is proportional model? Proportional model are manipulatives of exact equal size and ratio, such as base 10 blocks or beans glued together in a group of 10. It's all about size and ratio. Okay, now let's talk about the example of proportional models. The base 10 blocks, the number lines, glued together colored beans, and multiplication table timetable. Okay, later I will talk about what is the proportional though. Okay, how to represent numbers using proportional model. I give the example. You see the picture. the base 10 block, there is a 100, 10, and 1. So how can I describe this? Okay, the material for the 10 is 10 times the size of the material for 1. So the model that we use must be in the same size for 1 unit. Then the material for, so we can say that the material for 10, the 10 is 10 times the size of material 1. Then we can say that the material for the 100, this 100 is 10 times the size of material of 10. So you can see in this square is 1:10 equals to 10:100. So when we write in the fraction form, 1/10 is equal to 10/100. So okay, I'm sorry about the 100 this. So if 1:10 equals to 10:100, 100 ratio to is 1,000. So we can say that the material for the 1,000 is 10 times the material of 100. Okay, that's all for me. Next, we go to the non-proportional model.
Okay, next is non-proportional model. Non-proportional models include money, shapes, color, and others, or any manipulative where the size of the ones, tens, and hundreds are not proportional for the quantity they present. Manipulatives is not maintained and is not the clear focus. Next. Next is example of non-proportional model, which is the abacus, money, counters, and colored chips.
Okay, I will continue from Ain Yasira. So the non-proportional models, how to represent numbers using the non-proportional models. In money, topic money, teacher will compare the 1 ringgit note with the cent ceilings, but it doesn't mean that both is physically equal, although they have the same value. And then the teacher will compare the 1 ringgit and 10 ringgit, although they have very almost similar physical size, but it doesn't mean that 1 ringgit is physically 10. 10 ringgit is physically 10 times larger than 1 ringgit. I think that's all. Thank you.